Hello guys, in today's video we are going to cover Coulomb's law in vector form. Alright, vector form we are going to write. Previously we had done Coulomb's law only in magnitude, but in today's video we are going to see the force, Coulombian force in vector form. So let me consider two charges Q1 and Q2 which are placed at these two positions, which are having position vector as R1 vector and R2 vector. Alright, and suppose this point is A, this point is B. Right, for the time being let me consider these two charges both as positive. So if I write force on 1 due to 2, that must be definitely repulsive. Force on Q1 due to Q2, because I am considering both charges as like charges, so this is what force on 1 due to 2. Moreover, if I consider a position vector from B to A like this, this would be nothing, this is simply R21 vector, because this is from 2 to 1. Alright, so let me mention, in order to avoid any kind of confusion, let me mention this R2 vector, R21 vector. This is what, this is simply representing position vector of charge Q1 with respect to Q2. Right, and what does this F12 vector represent over here? This is electrostatic force on Q1 due to Q2. Alright, F12 is force on 1 due to Q2, while R21 is position vector 1 with respect to 2, right? So I think this part is clear to you all. Now if there is still some confusion, you find any difficulty, then please leave a comment so that I would be able to give you proper response, right? So now let's do one thing. Let's write first of all the force in magnitude form as per Coulomb's law. The Coulomb's law says that we had discussed in previous videos. As per Coulomb's law, we have a magnitude of force given by this relation F12 as 1 by 4 pi epsilon naught multiplied by Q1 Q2 divided by, here we have R square. Alright, this is magnitude form. Now we are going to make some change in this expression, because this magnitude is written over here right now. I'm going to because as per the requirement, this is our object. We are supposed to write Coulomb's law in vector form, and force is a vector quantity, so we must express this force in vector form. Let's do it. Again I'm going to write this force but in vector form. Okay, for vector we need magnitude, that we have already written. This is 1 by 4 pi epsilon naught Q1 Q2 by R square. But one more thing is needed over here, that is direction. And you can check this out from the diagram, that F12 vector is in same direction as that of R21 vector. Means I can represent the direction of F12 vector from the direction of R21 vector. And you might have heard about this, that direction is represented by unit vector, so I can write it as R21 cap. Alright, so now this has become, the expression in vector form, right? But this is, let's not call this as final formula, because this in any numerical, if it is required, we won't be able to use this formula directly, right? The formula we prefer to call as formula, that expression which can be used in any numerical kind of thing directly, right? So let's try to make some change in this. I'm going to multiply and divide, right? Multiplying and dividing above equation by R21 vector magnitude. So this implies that this expression would be like this, 1 by 4 pi epsilon naught into Q1 Q2. This is the magnitude written over here, and this is the magnitude of R21 vector, obviously, because this R is the distance between Q1 and Q2, which can be written as magnitude of R21 vector as well, because magnitude of any vector is what? Simply the length of this arrow, which is the distance between two charges. So I can I can rewrite this R as R21 vector magnitude, and square is already there. Now what I have done, I have multiplied this equation by r21 vector, and also I have divided this equation by r21 vector magnitude. Alright, so here I am going to get 1 by 4 pi epsilon naught into q1 q2 divided by, you can see this is square, and this r21 vector magnitude is already there. It will be making it as r21 vector magnitude q, and here we have unit vector multiplied with the magnitude of the vector, which makes it complete vector. So I can write it as complete vector. The reason is any vector can be written like this, like the product of magnitude with the unit vector. All right, so I am going to get the final formula, and this is let's say suppose equation 1. And now I'm going to use one more relation. If you check this direction, this triangle, in this triangle we have 3 vectors, and here 2 vectors. These 2 vectors are in same order. This is the third side, which is in reverse order. So as per triangle law of vector addition, applying triangle law of vector addition, we have the 2 sides in same order representing 2 vectors. These are r2 vector and r21 vector. So sum of these 2 vectors must be given by the third side in reverse order, which is already there. So I can write r2 vector plus r21 vector is equal to r1 vector. All right, so r21 vector would be r1 vector minus r2 vector. Now therefore equation 1 can be rewritten as now I'm going to get the final formula. f12 vector is equal to 1 by 4 pi epsilon naught into q1 q2 divided by magnitude of r1 minus r2 vector q multiplied by r1 vector minus r2 vector. Fantastic. So this is the final expression for the force in vector form. This is called Coulomb's law in vector form, and here we are able to find the symmetry. Like if you are supposed to write F12 means force on 1 due to 2, then you will be writing like R1 minus R2, right? 1 minus 2, right? In case suppose if you have F34 vector, then you will be writing R3 vector minus R4 vector. All right, in numerator especially, because in denominator you have magnitude, so it does not matter in denominator whether you write R1 minus R2 or R2 minus R2, both are going to give same value. All right, similarly I can write another force. The force experienced by another charged particle means 2 due to 1, and that can be written simply by interchanging 1 by 2, means it would be like r2 vector minus r1 vector magnitude cube into r2 vector minus r1 vector. Okay, so these are the forces in vector form. Moreover, if you check out these 2 equations, equation 2 and 3, you can say that f12 vector is equal to minus f21 vector, which is a very common and which was also expected, because this is in favor of Newton's third law of motion. This is a real force, so it must be following Newton's laws of motion. So it is what also following action reaction pair. So this was all about Coulomb's law in vector form. Again, the same thing I would like to mention, that if you find any difficulty in any step, please do me a favor, leave a comment for this. I'll be more than happy for that in giving a response, and I'll be trying to give quick response for every single doubt. Thanks for watching the video.